there are entrepreneurs, and then there is Elon Musk. While most business leaders focus on incremental improvements within existing markets, Musk creates entirely new industries. While others avoid risk and uncertainty, Musk seeks out the most challenging problems humanity faces and commits his life to solving them. While conventional wisdom suggests specializing in one area, Musk simultaneously revolutionizes electric vehicles, space exploration, neural interfaces, and underground transportation. This isn't just success. This is transformation at a scale that few individuals in history have achieved. Elon Musk has fundamentally altered how we think about sustainable energy, space travel, artificial intelligence, and the future of human civilization itself. His companies aren't just businesses. They're missions to secure humanity's future and expand our possibilities as a species. But what sets Musk apart isn't supernatural intelligence or unlimited resources. What distinguishes him is a unique approach to thinking and problem solving that can be learned, understood, and applied by anyone willing to challenge their assumptions about what's possible. This approach, what we call the innovation mindset, represents a fundamentally different way of engaging with problems, opportunities, and the future. Born in Pretoria, South Africa, in 1971, Musk displayed early signs of the thinking patterns that would later enable his extraordinary achievements. As a child, he was obsessed with understanding how things worked at their most fundamental level. He would take apart electronics, read encyclopedias voraciously, and ask relentless questions that often frustrated adults who couldn't provide satisfactory answers. This early pattern of deep curiosity, combined with hands-on experimentation, would become the foundation of Musk's innovation mindset. Unlike many successful entrepreneurs who excel at execution within existing frameworks, Musk excels at questioning the frameworks themselves and rebuilding them from the ground up when necessary. Musk's journey from a young boy fascinated by physics and programming to one of the world's most influential entrepreneurs demonstrates that innovation mindset isn't about having brilliant flashes of inspiration. It's about systematically approaching problems in ways that others don't. It's about seeing possibilities that others miss, not because of superior intelligence, but because of superior thinking processes. The innovation mindset that drives Musk's success consists of several interconnected mental frameworks that work together to create breakthrough thinking and breakthrough results. These frameworks aren't mysterious or supernatural. They're learnable approaches to problem solving that anyone can develop with practice and commitment. Throughout this audiobook, we'll explore 8 core components of Musk's innovation mindset. Each component represents a different aspect of how he approaches challenges, opportunities, and the process of building the future. Together, these components create a comprehensive system for thinking and acting that enables extraordinary results in any field or industry. The first framework we'll explore is first principles thinking, Musk's method for breaking down complex problems into their most fundamental components and rebuilding solutions from the ground up. This approach allows him to avoid the limitations of conventional wisdom and discover solutions that others miss because they're trapped by analogical thinking. Next, we'll examine mission-driven vision, Musk's approach to setting and pursuing goals that are so compelling and important that they provide unlimited motivation and attract the world's best talent. This framework shows how connecting personal ambition to larger purposes creates sustainable drive and enables achievement at scales that purely self-interested motivation cannot reach. We'll delve into iterative innovation, Musk's method for continuously improving products, processes, and systems through rapid cycles of experimentation, feedback, and refinement. This approach enables his companies to achieve technological progress at speeds that traditional development processes cannot match. The fourth framework, risk and failure embrace, reveals how Musk views uncertainty and setbacks as essential components of the innovation process rather than obstacles to be avoided. This perspective enables him to pursue opportunities that others consider too risky while learning and adapting faster when things don't go according to plan. Physics-based problem solving shows how Musk applies scientific principles and mathematical reasoning to business challenges, engineering problems, and strategic decisions. This framework provides a foundation for making decisions based on objective reality rather than subjective preferences or conventional assumptions. Long-term planning demonstrates how Musk balances visionary thinking about the future with practical execution in the present. This framework enables him to work toward goals that may take decades to achieve while making progress every day toward those ultimate objectives. Speed and Agility explores how Musk maintains rapid decision-making and execution capabilities even as his companies grow larger and more complex. This framework prevents the bureaucratic slowdown that typically accompanies organizational growth and maintains the entrepreneurial advantages that drive innovation. Finally, Building Future Industries examines how Musk identifies and creates entirely new markets rather than competing within existing ones. This framework reveals the thinking processes that enable him to see opportunities for transformation that others miss and build the infrastructure necessary to make those transformations reality. Each of these frameworks represents a different lens through which Musk views problems and opportunities. Individually, each provides valuable insights for improving thinking and decision-making. Together, they create a comprehensive approach to innovation that has enabled Musk to achieve results that most people consider impossible. The goal of this exploration isn't to transform you into Elon Musk. That's neither possible nor necessary. The goal is to understand the thinking patterns that enable extraordinary innovation and apply those patterns to your own challenges, opportunities, and aspirations. Whether you're building a business, developing a career, solving technical problems, or simply trying to think more effectively, the frameworks that drive Musk's success can enhance your capabilities and expand your possibilities. The innovation mindset isn't reserved for billionaire entrepreneurs or rocket scientists. It's available to anyone willing to question assumptions, embrace uncertainty, think systematically, and commit to continuous learning and improvement. The same thinking patterns that enable Musk to build revolutionary companies can enable you to achieve breakthrough results in whatever area you choose to apply them. As we begin this journey into the mind of one of history's most successful innovators, prepare to challenge your own assumptions about what's possible. Prepare to think differently about problems, opportunities, and the process of creating solutions. Prepare to develop the mental frameworks that enable extraordinary achievement and lasting impact. The future belongs to those who can think beyond current limitations and build solutions to humanity's greatest challenges. Elon Musk's innovation mindset provides a proven blueprint for that kind of thinking. Now it's time to make that blueprint your own. Chapter 1. First Principles Thinking. At the heart of Elon Musk's revolutionary success lies a mental framework that most people never learn to use effectively. First Principles Thinking. This approach has enabled Musk to achieve breakthroughs that others considered impossible, not because he's inherently smarter than other entrepreneurs, but because he approaches problems in a fundamentally different way. First Principles Thinking is the practice of breaking down complex problems into their most basic, foundational elements, the fundamental truths that cannot be reduced further, and then reasoning up from those foundations to build new solutions. Instead of reasoning by analogy or following conventional approaches, this method requires stripping away all assumptions, conventional wisdom, and inherited beliefs to understand what's actually true at the most basic level. Most people think by analogy, unconsciously copying what others have done with minor modifications. They see how problems have been solved in the past and try to improve on existing solutions incrementally. This approach works well for optimization within existing paradigms, but it prevents the kind of breakthrough thinking that creates entirely new possibilities. Musk learned first principles thinking from his deep study of physics, where this approach is essential for understanding how the universe actually works. In physics, you can't rely on what seems intuitive or what has worked before. You must understand the fundamental laws and principles that govern reality and reason forward from those unchangeable truths. This scientific training fundamentally shaped how Musk approaches business problems, engineering challenges, and strategic decisions. Instead of asking, how have others solved similar problems? He asks, what are the fundamental physical and economic constraints that define this problem? And what solutions become possible when we reason up from those constraints? The power of first principles thinking becomes clear when you examine how Musk applied it to revolutionize the space industry. For decades, everyone in aerospace assumed that rockets were inherently expensive because they could only be used once. This assumption was based on analogy. Rockets had always been disposable, so they must need to be disposable. But when Musk applied first principles thinking to the problem, he asked different questions. What are the fundamental physical requirements for getting objects into space? What are the actual material and energy costs involved? Why do rockets need to be thrown away after single use? From this analysis, Musk realized that the fundamental physics of rocket propulsion didn't require disposability. The materials costs of rockets weren't prohibitively expensive. Most of the cost came from the assumption that each rocket could only be used once. By designing rockets for reusability from the ground up, SpaceX could reduce launch costs by orders of magnitude. This insight seems obvious in retrospect, but it was revolutionary when Musk proposed it because the entire aerospace industry was trapped by analogical thinking. They were incrementally improving on existing approaches rather than questioning whether those approaches made sense at the fundamental level. Musk applied the same first principles approach to revolutionize the automotive industry. Instead of asking, how can we make better gasoline cars? He asked, what is the fundamental purpose of personal transportation, and what technologies could fulfill that purpose most effectively? This analysis led him to recognize that electric powertrains were fundamentally superior to internal combustion engines for most transportation needs. They were more efficient, simpler, more reliable, and could be powered by clean energy. The only reason electric vehicles weren't dominant was that battery technology hadn't reached sufficient cost and performance levels, not because electric propulsion was inherently inferior. By focusing on advancing battery technology through first principles analysis of materials science and manufacturing processes, Tesla was able to achieve the breakthroughs necessary to make electric vehicles competitive with and eventually superior to gasoline vehicles. The first principles approach also revealed opportunities that analogical thinking missed. Most automakers viewed cars as mechanical products that happened to have some electronic components. But first principles analysis suggested that cars were increasingly becoming computers with wheels, mobile platforms for software, sensors, and artificial intelligence. This insight led Tesla to design vehicles from the ground up as software-defined products with over-the-air update capabilities, autonomous driving potential, and integrated energy systems. While other manufacturers were still thinking about incremental improvements to traditional automotive designs, Tesla was building the foundation for an entirely different kind of transportation system. Musk's application of first principles thinking to battery technology provides another powerful example of this approach. When Tesla needed batteries for their vehicles, most people assumed they would need to accept whatever pricing and performance the established battery manufacturers offered. The conventional approach would have been to negotiate better deals or find alternative suppliers. But Musk applied first principles analysis to the battery problem. What are batteries actually made of at the material level? What do those raw materials cost? What are the fundamental physical and chemical processes required to combine those materials into functional batteries? What are the theoretical limits of performance and cost for different battery chemistries? This analysis revealed that batteries were being sold for far more than their fundamental material and processing costs would justify. By understanding battery technology at the first principles level, Tesla was able to work with suppliers to dramatically reduce costs while simultaneously improving performance. The same approach applied to manufacturing processes, supply chain optimization, and product design across all of Musk's companies. Instead of accepting industry norms and conventional wisdom, Each problem is broken down to its fundamental components and rebuilt from the ground up. First principles thinking requires several key mental disciplines that most people never develop. The first is the intellectual humility to admit that conventional approaches might be wrong, even when they're widely accepted and have worked in the past. This requires overcoming the cognitive bias toward authority and consensus that normally guides human decision-making. The second discipline is the patience and analytical rigor required to break complex problems down into their fundamental components. This process is often time-consuming and mentally challenging because it requires understanding systems at deeper levels than most people ever attempt. The third discipline is the creativity and synthesis capability required to build new solutions from fundamental components. Even after you understand a problem at the first principles level, you still need to imagine new ways of combining those principles to create solutions that haven't existed before. The fourth discipline is the courage to act on insights that contradict conventional wisdom, especially when those insights suggest pursuing approaches that others consider impossible or impractical. Developing first principles thinking capability begins with cultivating curiosity about how things actually work at the most fundamental level. Instead of accepting systems, processes, and solutions as given, practice asking why they work the way they do and whether alternative approaches might be superior. This curiosity should extend beyond your immediate field of expertise to include understanding of physics, mathematics, economics, psychology, and other disciplines that reveal fundamental principles about how reality operates. The broader your base of fundamental knowledge, the more effectively you can apply first principles thinking to novel problems. Practice breaking down familiar problems and solutions into their component parts, identifying which elements are truly necessary versus which exist for historical or conventional reasons. Challenge yourself to rebuild solutions from scratch using only the elements that serve essential functions. Most importantly, develop comfort with uncertainty and complexity. First principles thinking often reveals that problems are more complicated than they initially appear, but also that they contain more opportunities for innovation than conventional approaches suggest. Musk's success demonstrates that first principles thinking isn't just an intellectual exercise. It's a practical approach to problem solving that enables breakthrough innovations and competitive advantages that analogical thinking cannot achieve. By learning to think from fundamental principles rather than inherited assumptions, anyone can develop the mental framework that enables extraordinary innovation and success. Chapter 2: Mission-Driven Vision. While most entrepreneurs are motivated primarily by financial success or personal achievement, Elon Musk operates from a fundamentally different source of motivation: mission-driven vision. His companies aren't just businesses designed to generate profits. They're instruments for accomplishing specific, transformational missions that have profound implications for humanity's future. This mission-driven approach provides several powerful advantages that conventional profit-motivated entrepreneurship cannot match. It creates unlimited motivation that persists through setbacks and challenges that would discourage purely financially motivated individuals. It attracts the world's best talent who want to work on meaningful problems rather than incremental improvements to existing products. It inspires customer loyalty and investor confidence by connecting commercial success to larger purposes that people want to support. Perhaps most importantly, mission-driven vision provides clarity and focus that enables better decision-making and strategic direction. When every decision can be evaluated against the mission's requirements, complex trade-offs become simpler and organizational alignment becomes easier to achieve. Musk's missions are not modest or incremental. They address some of the most significant challenges and opportunities facing human civilization. Tesla's mission is to accelerate the world's transition to sustainable energy, addressing climate change while proving that sustainable technologies can be superior to fossil fuel alternatives. SpaceX's mission is to make humanity a multi-planetary species, ensuring species survival while opening unlimited opportunities for growth and exploration. These missions are carefully chosen to be both personally compelling to Musk and objectively important for humanity's future. They provide meaning that transcends personal ambition while creating business opportunities that can generate the resources necessary to accomplish the missions. The mission-driven approach influences every aspect of how Musk builds and operates his companies. Hiring decisions prioritize candidates who are motivated by the mission rather than just compensation or career advancement. Product development decisions prioritize features and capabilities that advance the mission rather than just maximizing short-term profits. Strategic partnerships are evaluated based on mission alignment rather than just financial terms. This mission alignment creates organizational cultures that are more resilient, innovative, and committed than traditional profit-maximizing cultures. When employees understand that their work contributes to important missions, they're willing to work harder, take more risks, and persist through difficulties that would cause others to give up. Musk's ability to communicate his missions effectively plays a crucial role in building the support necessary for their accomplishment. He doesn't just describe what his companies do. He explains why they exist and how their success contributes to larger purposes that everyone can understand and appreciate. This communication includes storytelling that makes abstract missions concrete and relatable. Instead of just talking about sustainable energy in general terms, Musk explains specifically how Tesla's products eliminate emissions, reduce energy costs, and create energy independence. Instead of just discussing space exploration abstractly, he describes specifically how making life multiplanetary protects against existential risks and opens unlimited opportunities for human expansion. The mission-driven approach also influences how Musk thinks about timelines and resource allocation. Because his missions are inherently long-term, transitioning global energy systems and establishing sustainable human presence on Mars are multi-decade undertakings. He's willing to make investments and accept short-term costs that purely profit-driven companies would avoid. This long-term perspective enables innovations and market positioning that create sustainable competitive advantages. While competitors focus on quarterly earnings and immediate market share, Musk's companies build capabilities and infrastructure that serve the missions over decades. Tesla's supercharger network exemplifies this long-term, mission-driven approach. Building charging infrastructure required massive upfront investment with uncertain returns, but it was essential for accomplishing Tesla's mission of accelerating sustainable transportation adoption. By viewing the supercharger network as mission-critical infrastructure rather than a separate profit center, Tesla created a competitive advantage that traditional automakers couldn't replicate quickly. Similarly, SpaceX's investment in reusable rocket technology required years of development and testing before generating positive returns. But it was essential for accomplishing the mission of making space access affordable enough to support Mars colonization. By maintaining focus on the long-term mission rather than short-term profitability, SpaceX achieved breakthroughs that transformed the space industry. Mission-driven vision also provides resilience during inevitable setbacks and failures. When Tesla faced production challenges, supply chain disruptions, and skepticism from industry experts, Musk's commitment to the sustainable energy mission provided motivation to persist through problems that might have caused other entrepreneurs to abandon their efforts. When SpaceX experienced rocket failures, regulatory delays, and technical setbacks, Musk's commitment to the Mars mission provided context that framed these challenges as learning experiences rather than reasons for discouragement. The mission perspective transforms obstacles from threats into problem-solving opportunities. The mission-driven approach requires careful balance between idealistic vision and practical execution. Missions must be inspiring enough to provide unlimited motivation, but realistic enough to be achievable through systematic effort. They must address genuinely important problems, but also create viable business models that can finance their accomplishment. Musk achieves this balance by combining visionary end goals with pragmatic intermediate milestones. Tesla's ultimate mission of sustainable energy transformation is supported by practical near-term goals of producing attractive, high-performance electric vehicles that customers want to buy. SpaceX's ultimate mission of Mars colonization is supported by practical near-term goals of providing reliable, cost-effective launch services that generate revenue. This structure enables mission-driven companies to maintain visionary motivation while building sustainable businesses that can persist long enough to accomplish their missions. It prevents the idealism trap that causes some mission-driven ventures to fail commercially, and it prevents the cynicism trap that causes some commercially successful ventures to lose their motivational power. For entrepreneurs seeking to apply mission-driven vision to their own ventures, the process begins with identifying problems or opportunities that are both personally meaningful and objectively important. The mission should connect your deepest values and interests to challenges or possibilities that matter for many other people as well. The mission should be specific enough to provide clear direction for decision-making, but broad enough to encompass multiple business opportunities and strategic approaches. It should be ambitious enough to provide unlimited motivation, but grounded enough in reality to be achievable through systematic effort. Most importantly, the mission should be authentic rather than manufactured. Genuine mission-driven motivation comes from connecting your work to purposes that you actually care about, not from adopting missions that seem strategically advantageous, but don't resonate personally. Musk's example demonstrates that mission-driven vision isn't just idealistic thinking. It's a practical approach to entrepreneurship that enables sustained motivation, attracts superior talent, creates customer loyalty, and provides strategic focus that generates competitive advantages impossible to achieve through purely profit-motivated approaches. By connecting business success to meaningful missions, entrepreneurs can build companies that accomplish more than anyone thought possible while creating value that extends far beyond financial returns. Chapter 3: Iterative Innovation. While most companies spend years developing products in secret before revealing them to the world, Elon Musk has built his success on a completely different approach: iterative innovation. This methodology emphasizes launching products early, gathering real-world data quickly, and continuously improving through rapid cycles of development, testing, and refinement. This approach has enabled Musk's companies to achieve breakthrough innovations faster and more reliably than traditional development processes could accomplish. Iterative innovation represents a fundamental shift from the perfectionist mindset that dominates most industries. Instead of trying to create flawless products before launch, Musk focuses on creating functional products that can be improved systematically through experience and feedback. This approach recognizes that real-world usage provides information that no amount of theoretical analysis or laboratory testing can replace. The power of iterative innovation lies in its ability to compress learning cycles and accelerate the pace of improvement. Traditional development approaches often spend years refining products based on assumptions about customer needs and market conditions. By the time these products reach the market, many of those assumptions prove incorrect, requiring expensive redesigns and delays. Musk's approach inverts this process. Instead of spending years perfecting products based on assumptions, his companies launch functional products quickly and use customer feedback and performance data to guide improvements. This approach ensures that development efforts focus on solving real problems rather than theoretical ones. Tesla's development history perfectly illustrates the power of iterative innovation. The original Roadster was far from perfect when it launched in 2008. It had limited range, high costs, and numerous quality issues. Traditional automotive thinking would have viewed these imperfections as failures that should have been resolved before launch. But Musk understood that launching the Roadster, despite its imperfections, would generate invaluable data about electric vehicle performance, customer preferences, and market dynamics that couldn't be obtained any other way. Each Roadster sold provided information about battery performance under real-world conditions, customer usage patterns, and the infrastructure requirements for electric vehicle adoption. This information guided the development of the Model S, which addressed many of the Roadster's limitations while introducing new capabilities based on what Tesla had learned from early customers. The Model S data, in turn, informed the development of the Model 3, Model Y, and subsequent vehicles, each representing significant improvements over previous iterations. This iterative approach enabled Tesla to improve its vehicles at a pace that traditional automakers couldn't match. While established manufacturers were still conducting theoretical studies about electric vehicle feasibility, Tesla was accumulating real-world experience and using it to create better products. SpaceX's development of reusable rockets demonstrates iterative innovation applied to an even more challenging domain. When Musk announced SpaceX's intention to develop reusable launch vehicles, most aerospace experts considered the goal impossible or impractical. Traditional aerospace development would have spent years on theoretical studies and simulations before attempting actual flights. Instead, SpaceX began flight testing early versions of reusable rocket technology, accepting that many early attempts would fail, but recognizing that each failure would provide crucial information for subsequent iterations. The company's first attempts at rocket recovery were spectacular failures that generated valuable data about aerodynamics, control systems, and landing procedures. Each failure informed improvements in the next iteration, gradually developing the capabilities necessary for successful rocket recovery and reuse. This iterative approach enabled SpaceX to achieve reusable rocket technology years ahead of competitors who were still conducting theoretical studies. The iterative approach requires creating organizational cultures that support rapid experimentation and learning from failures. This means establishing psychological safety where employees feel comfortable proposing bold ideas, conducting experiments, and reporting results honestly even when those results indicate failure. Musk personally models this behavior by openly discussing failures and setbacks rather than trying to hide or minimize them. When SpaceX rockets explode during testing, Musk shares videos of the failures and explains what was learned from each incident. When Tesla vehicles experience quality issues, the company uses the problems as opportunities to improve manufacturing processes and product design. This transparency about failures creates organizational cultures where learning is valued more than perfection, enabling faster iteration cycles and more effective problem solving. Employees understand that their job isn't to avoid failures, but to fail quickly and learn efficiently when failures occur. Iterative innovation also requires developing systems and processes that can handle rapid change and continuous improvement. Traditional organizational structures and procedures are often designed for stability and consistency, making them poorly suited for environments where rapid iteration is essential. Musk's companies have developed flexible organizational structures, streamlined decision-making processes, and communication systems that support rapid iteration cycles. Engineers can quickly implement changes, test new approaches, and incorporate feedback without being slowed by bureaucratic approval processes or rigid procedures. The technological infrastructure supporting iterative innovation is equally important. Tesla's vehicles are designed as software-defined platforms that can be updated and improved through over-the-air software updates. This capability enables continuous improvement of vehicle performance, features, and capabilities even after vehicles are sold to customers. SpaceX uses advanced simulation and modeling capabilities to test design changes rapidly and predict their effects before implementing them in physical hardware. This simulation capability enables more iteration cycles by reducing the time and cost required for each iteration. The customer relationship dimension of iterative innovation requires maintaining open communication channels with users and incorporating their feedback into development priorities. Musk personally engages with customers through social media, gathering feedback and suggestions that influence product development decisions. This direct customer engagement creates feedback loops that inform iterative improvements and ensure that development efforts focus on features and capabilities that customers actually value. It also creates customer loyalty by demonstrating that the companies are responsive to user needs and committed to continuous improvement. Iterative innovation extends beyond product development to business model innovation, operational improvements, and strategic planning. Musk's companies continuously experiment with new approaches to manufacturing, distribution, customer service, and market positioning, using results from these experiments to refine their strategies. This comprehensive approach to iteration creates organizations that can adapt quickly to changing conditions and continuously improve their performance across all dimensions of their operations. It prevents the stagnation that often affects successful companies as they grow larger and more established. The competitive advantages created by iterative innovation compound over time. Companies that iterate faster learn faster, improve faster, and adapt faster than competitors using traditional development approaches. These advantages become more pronounced as markets become more dynamic and competitive. For entrepreneurs seeking to apply iterative innovation to their own ventures, the process begins with shifting from perfectionist thinking to learning thinking. Instead of asking, how can we make this perfect before launching? Ask, how can we launch something functional and improve it based on real experience? This shift requires developing comfort with uncertainty and imperfection, focusing on learning velocity rather than initial quality, and building systems that support rapid iteration rather than stability and consistency. The implementation of iterative innovation also requires careful balance between speed and quality. While rapid iteration enables faster learning, products still need to meet basic functionality and safety requirements. The goal is to launch products that are good enough to provide value while being imperfect enough to benefit from improvement. Musk's success demonstrates that iterative innovation isn't just a development methodology. It's a comprehensive approach to business building that enables faster learning, better products, and stronger competitive positions. By embracing iteration as a core principle, entrepreneurs can accelerate their progress toward breakthrough innovations and transformative success. Chapter 4: Risk and Failure Embrace. Perhaps no aspect of Elon Musk's mindset is more crucial to his extraordinary success than his relationship with risk and failure. While most entrepreneurs spend enormous energy trying to minimize risk and avoid failure, Musk has built his fortune by embracing both as essential elements of breakthrough innovation. His approach transforms what others see as threats into competitive advantages, enabling him to pursue opportunities that others consider too dangerous while learning and adapting faster than competitors who play it safe. Musk's relationship with risk is fundamentally different from both reckless gambling and conservative risk avoidance. He doesn't seek risk for its own sake, nor does he try to eliminate all uncertainty from his ventures. Instead, he approaches risk systematically, carefully evaluating potential outcomes while accepting that extraordinary results require accepting extraordinary risks. This calculated approach to risk-taking begins with understanding that different types of risk require different management strategies. Technical risks, the possibility that new technologies won't work as expected, can be managed through iterative development, extensive testing, and having multiple approaches to solving the same problems. Market risks, the possibility that customers won't want new products, can be managed through customer research, prototype testing, and gradual market introduction. Financial risks, the possibility that ventures won't generate sufficient returns to justify their costs, can be managed through careful capital allocation, maintaining reserves for unexpected challenges, and structuring investments to limit downside exposure while preserving upside potential. But Musk also recognizes that some risks simply cannot be eliminated through management techniques. When you're trying to develop reusable rockets, create mass-market electric vehicles, or establish sustainable human presence on Mars, you're inherently working in domains where the probability of failure is high and the challenges are largely unprecedented. Traditional risk management approaches would suggest avoiding these domains entirely, but Musk understands that the potential rewards of success in these areas are so enormous that accepting high failure probabilities can be the most rational strategy available. This insight requires a fundamental shift in thinking about the relationship between risk and reward. Instead of viewing risk as the price you pay for potential rewards, Musk views risk as the filter that prevents most people from pursuing the highest value opportunities. If something were guaranteed to succeed, everyone would be doing it, and the potential returns would be bid down to ordinary levels. The willingness to accept high risk, high reward opportunities creates access to possibilities that are unavailable to more risk averse competitors. When SpaceX was developing reusable rocket technology, established aerospace companies avoided similar investments because the probability of failure was too high for their risk tolerance. This risk aversion created an opportunity for SpaceX to achieve breakthrough capabilities that transformed the entire industry. Musk's approach to failure is equally sophisticated and equally crucial to his success. Rather than viewing failure as evidence of inadequacy or reasons for discouragement, he views failures as information that accelerates learning and improvement. This perspective transforms failure from an obstacle into a tool for competitive advantage. The key insight is that failure provides information that success cannot provide. When something works as expected, you learn that your approach was adequate, but you don't learn much about alternative approaches that might be superior. When something fails, you learn specific information about what doesn't work and why, which guides you toward approaches that might work better. This learning advantage from failure is most valuable when you can fail quickly and cheaply while your competitors are still trying to avoid failure entirely. While they're conducting extensive studies and analyses to minimize failure probability, you can be conducting actual experiments that generate real data about what works and what doesn't. SpaceX's development of rocket landing technology perfectly illustrates this approach. The company's early landing attempts failed spectacularly, producing dramatic explosions that attracted widespread media attention and criticism. Traditional aerospace thinking would have viewed these failures as embarrassing setbacks that should be avoided through more extensive ground testing and simulation. But Musk understood that each failure provided specific information about aerodynamics, control systems, and landing procedures that couldn't be obtained through simulation alone. The explosions weren't setbacks. They were experiments that generated data necessary for developing successful landing capabilities. By embracing these failures as learning opportunities, rather than trying to avoid them, SpaceX was able to develop reusable rocket technology years ahead of competitors who were still trying to perfect their approaches through theoretical analysis before attempting actual flights. This approach to failure requires creating organizational cultures that support experimentation and learning rather than blame and punishment when things go wrong. Employees need to feel safe reporting problems, proposing risky ideas, and acknowledging when their approaches aren't working. Musk models this behavior personally by discussing failures openly rather than trying to hide or minimize them. When Tesla faces production challenges or SpaceX experiences launch failures, Musk explains what happened, what was learned, and how the lessons will be applied to future attempts. This transparency creates trust and encourages honest reporting of problems throughout his organizations. The cultural support for intelligent failure extends to hiring and evaluation practices. Musk's companies seek employees who have experience taking risks and learning from setbacks rather than just candidates with records of uninterrupted success. They understand that people who have never failed may lack the resilience and learning capability necessary for breakthrough innovation. Performance evaluation focuses on learning velocity and adaptive capability rather than just avoiding mistakes. Employees are rewarded for taking calculated risks, reporting problems quickly, and applying lessons learned from failures to improve future performance. This culture of intelligent risk-taking and failure-based learning creates organizational capabilities that enable faster innovation cycles and more effective problem-solving than risk-averse cultures can achieve. Musk's approach to risk and failure also requires maintaining adequate resources to survive setbacks and continue operations through difficult periods. This doesn't mean avoiding risk, but it does mean structuring ventures so that individual failures don't threaten overall mission accomplishment. Tesla and SpaceX have both faced periods where individual projects failed or encountered major setbacks, but both companies maintained sufficient resources and multiple development programs to continue pursuing their missions despite these challenges. This portfolio approach to risk management enables pursuit of high-risk opportunities while maintaining organizational survival capability. Instead of betting everything on single approaches, Musk's companies typically pursue multiple approaches to solving the same problems, knowing that some will fail, but confident that some will succeed. The psychological dimension of embracing risk and failure requires developing emotional resilience and maintaining long-term perspective during inevitable setbacks. This means separating personal identity from business outcomes, viewing failures as information rather than judgments, and maintaining confidence in ultimate mission accomplishment despite temporary obstacles. Musk's public persona demonstrates this emotional resilience. Despite facing constant criticism, high-profile failures, and enormous pressure, he maintains focus on long-term missions rather than becoming discouraged by short-term setbacks. For entrepreneurs seeking to apply similar approaches to risk and failure, the process begins with reframing these concepts from threats to be avoided into tools for competitive advantage. This requires developing comfort with uncertainty, building systems for rapid experimentation and learning, and creating cultures that reward intelligent risk-taking rather than just avoiding mistakes. The implementation of risk, embracing, and failure-positive approaches requires careful balance between boldness and prudence. The goal isn't to be reckless or to fail for its own sake, but to accept that breakthrough innovations require accepting higher failure probabilities in exchange for access to higher value opportunities. Musk's success demonstrates that the willingness to embrace risk and failure isn't just about courage or tolerance for discomfort. It's about recognizing that these elements are essential tools for achieving extraordinary results. By learning to use risk and failure strategically rather than avoiding them defensively, entrepreneurs can access opportunities and develop capabilities that more conservative approaches cannot achieve. Chapter 5: Physics-Based Problem Solving. One of the most distinctive aspects of Elon Musk's approach to business and engineering challenges is his systematic application of physics principles and scientific reasoning to problem solving. While most business leaders rely on intuition, conventional wisdom, or MBA frameworks, Musk approaches problems like a physicist, seeking to understand the fundamental laws and principles that govern systems before attempting to optimize or improve them. This physics-based approach provides several crucial advantages that conventional business thinking cannot match. It grounds decision-making in objective reality rather than subjective preferences or popular trends. It reveals opportunities for improvement that aren't visible through traditional business analysis. It enables breakthrough innovations that violate conventional industry assumptions, but align with physical and mathematical realities. Musk's physics background. He studied physics at the University of Pennsylvania and was accepted to Stanford's PhD program in applied physics, fundamentally shaped how he approaches all problems, whether they involve rocket design, battery technology, manufacturing processes, or business strategy. Physics thinking begins with identifying the fundamental constraints and possibilities that define any system. Before trying to optimize a system's performance, you must understand what physical laws govern its operation, what theoretical limits constrain its possibilities, and what trade-offs are inherent in its design. This approach contrasts sharply with conventional business thinking, which often focuses on competitive benchmarking, market positioning, and customer preferences without deeply understanding the underlying systems being optimized. When Musk analyzed the automotive industry, he didn't just study market segments, consumer preferences, and competitive positioning. He studied the fundamental physics of energy conversion, storage, and propulsion. This analysis revealed that electric powertrains were inherently more efficient than internal combustion engines, converting energy to motion with much higher efficiency and requiring far fewer moving parts. This physics-based insight suggested that electric vehicles could eventually be superior to gasoline vehicles in performance, reliability, and cost, despite current market conditions that favored internal combustion technology. The physics analysis provided confidence to pursue electric vehicle development, even when conventional market analysis suggested it was a poor business opportunity. Similarly, when Musk analyzed the space launch industry, he applied physics principles to understand the fundamental cost drivers of rocket propulsion. This analysis revealed that the raw materials costs of rockets were relatively small compared to their sale prices, suggesting that reusability could dramatically reduce launch costs if technical challenges could be solved. The physics-based analysis provided both a vision for reusable rockets and the confidence to invest in developing the technology despite industry skepticism about its feasibility. Musk's approach to manufacturing also demonstrates physics-based thinking applied to business processes. Instead of accepting industry norms for production rates, quality levels, or cost structures, he analyzes manufacturing processes from physics principles to identify theoretical limits and optimization opportunities. This approach led Tesla to redesign automotive manufacturing from the ground up, applying principles from semiconductor manufacturing, aerospace production, and other industries to create production systems that could achieve higher quality and lower costs than traditional automotive manufacturing approaches. The physics-based approach also influences how Musk thinks about scaling and growth. Rather than using conventional business metrics to evaluate scaling opportunities, he analyzes the mathematical relationships between scale and efficiency, identifying areas where larger scale creates exponential rather than linear improvements. This analysis revealed that battery manufacturing, charging infrastructure, and autonomous driving technology all exhibit strong scaling advantages where increased volume creates dramatically better unit economics and performance characteristics. Understanding these scaling dynamics through physics-based analysis enabled Tesla to make investments in manufacturing capacity and technology development that seemed excessive by conventional business standards, but were actually essential for achieving the scale advantages necessary for long-term success. Physics-based problem solving also provides clarity about what is possible versus what is merely difficult. Many business challenges that seem insurmountable through conventional analysis become more tractable when approached from physics principles. When Tesla was developing battery technology, conventional analysis suggested that battery costs and performance were limited by existing supplier capabilities. But physics-based analysis of battery chemistry, materials science, and manufacturing processes revealed that much better performance and lower costs were theoretically possible if the right approaches could be developed. This physics-based confidence enabled Tesla to invest in battery research and manufacturing capabilities that eventually achieved the breakthroughs necessary for mass-market electric vehicles. The application of physics thinking to business strategy requires developing several specific capabilities. The first is systems thinking, the ability to understand how components interact within larger systems and how changes in one area affect overall system performance. This systems perspective enables identification of leverage points where small changes can create large improvements, and it prevents optimization efforts that improve individual components while degrading overall system performance. The second capability is quantitative analysis, the ability to model system behavior mathematically and use data to validate theoretical predictions. This capability enables more accurate predictions about the effects of proposed changes and more objective evaluation of alternative approaches. The third capability is experimental design, the ability to structure tests that generate reliable information about system behavior while controlling for confounding variables. This capability enables efficient learning about complex systems where theoretical analysis alone is insufficient. Musk's companies demonstrate all of these capabilities in their approach to product development, manufacturing optimization, and strategic planning. They use sophisticated mathematical models to predict system behavior, conduct carefully designed experiments to validate theoretical predictions, and apply systems thinking to identify optimization opportunities. The cultural implementation of physics-based thinking requires creating organizational environments that value objective analysis over subjective preferences, data over opinions, and theoretical understanding over conventional wisdom. This means hiring people with strong analytical capabilities, providing them with tools and data necessary for rigorous analysis, and creating decision-making processes that emphasize evidence-based reasoning. It also means maintaining healthy skepticism about conventional industry practices and popular trends, always asking whether current approaches are actually optimal or just historically entrenched. For entrepreneurs seeking to apply physics-based problem solving to their own ventures, the process begins with developing stronger quantitative and analytical capabilities. This might involve studying mathematics, physics, engineering, or other technical disciplines that provide tools for understanding system behavior. It also involves adopting systematic approaches to problem analysis that begin with understanding fundamental constraints and possibilities before attempting optimization or innovation. The implementation of physics-based thinking requires patience and discipline, because it often reveals that popular approaches are suboptimal while suggesting alternatives that seem counterintuitive or difficult to implement. But Musk's success demonstrates that physics-based problem solving provides sustainable competitive advantages that conventional business thinking cannot match. By grounding decisions in objective reality rather than subjective preferences, entrepreneurs can identify opportunities and develop solutions that others miss because they're trapped by conventional assumptions and industry practices. Chapter 6: Long-Term Planning. Perhaps one of the most remarkable aspects of Elon Musk's innovation mindset is his ability to balance visionary long-term thinking with pragmatic short-term execution. While most entrepreneurs focus on quarterly results or annual milestones, Musk consistently operates with decades-long time horizons while maintaining urgent execution in the present moment. This long-term planning capability enables him to pursue missions that others consider impossibly ambitious while building sustainable businesses that can persist through the extended timelines required for transformational change. Musk's long-term thinking begins with identifying problems and opportunities that are genuinely important for humanity's future rather than just profitable in the short term. Climate change, sustainable energy, space exploration, artificial intelligence, and neural interfaces represent challenges and possibilities that will shape human civilization over decades and centuries, not just years. By focusing on these long-term challenges, Musk ensures that his work contributes to outcomes that matter far beyond immediate financial returns. This focus creates meaning and motivation that sustains effort through inevitable setbacks, and provides clarity about what work is worth doing versus what work is merely convenient or profitable. The long-term orientation also enables Musk to make investments and strategic decisions that would seem irrational from shorter-term perspectives. Building global charging infrastructure for electric vehicles required massive upfront investment with uncertain payback periods, but it was essential for achieving the long-term mission of sustainable transportation adoption. Developing reusable rocket technology required years of expensive failures and technical setbacks, but it was necessary for achieving the long-term mission of making space access affordable enough to support Mars colonization. This willingness to accept short-term costs for long-term benefits provides competitive advantages that shorter-term competitors cannot match. While others optimize for immediate profitability, Musk's companies build capabilities and infrastructure that create sustainable competitive advantages over decades. The long-term perspective also influences how Musk thinks about technology development and market timing. Instead of just building products for current market conditions, he anticipates how markets will evolve and positions his companies to serve future needs rather than just present demands. Tesla's focus on software-defined vehicles and autonomous driving capabilities reflects long-term vision about how transportation will evolve rather than just optimization for current customer preferences. SpaceX's development of Starship for Mars missions reflects long-term vision about space exploration needs rather than just current satellite launch demand. This forward-looking approach enables Musk's companies to shape markets rather than just responding to them. By the time competitors recognize emerging trends, Musk's companies have already built the capabilities necessary to serve those trends profitably. The implementation of long-term planning requires sophisticated approaches to goal setting and milestone management. Musk doesn't just set distant vision statements. He breaks down long-term missions into intermediate objectives and near-term milestones that provide direction for daily operations while maintaining focus on ultimate goals. Tesla's mission of sustainable energy transformation is supported by specific objectives like reducing battery costs, expanding manufacturing capacity, and improving vehicle performance that can be measured and achieved incrementally while contributing to the larger mission. SpaceX's mission of Mars colonization is supported by specific technical milestones like developing reusable rockets, perfecting life support systems, and reducing launch costs that can be achieved systematically while building capabilities for the ultimate objective. This hierarchical approach to goal setting creates organizational alignment around long-term missions while providing short-term focus and motivation for teams working on specific technical challenges. Long-term planning also requires developing organizational cultures and business models that can sustain extended development cycles and delayed gratification. Most companies are structured to optimize for quarterly earnings and annual growth targets, making them poorly suited for pursuing objectives that require decade-long development timelines. Musk's companies have developed patient capital structures, long-term employment relationships, and performance measurement systems that support extended innovation cycles rather than demanding immediate returns on all investments. This organizational patience enables pursuit of breakthrough innovations that require sustained effort over multiple years rather than just incremental improvements that can be achieved quickly. The financial dimension of long-term planning requires maintaining sufficient resources to survive inevitable setbacks and funding gaps while building toward distant objectives. Long-term missions often involve periods where costs exceed revenues significantly, requiring access to capital sources that share long-term vision rather than demanding immediate profitability. Musk has consistently structured his companies' financing to support long-term objectives, sometimes accepting higher capital costs in exchange for maintaining strategic flexibility and mission alignment. This financial patience enables his companies to make the investments necessary for achieving breakthrough capabilities rather than being forced to optimize for short-term cash flow at the expense of long-term potential. The psychological dimension of long-term planning requires maintaining motivation and confidence through extended periods where progress may be slow, setbacks are frequent, and external criticism is intense. Long-term missions inevitably involve periods where immediate results don't justify the effort being invested, requiring faith in ultimate outcomes despite current difficulties. Musk maintains this psychological resilience by connecting daily activities to larger purposes, celebrating intermediate achievements while maintaining focus on ultimate objectives, and viewing setbacks as temporary obstacles rather than permanent barriers. This psychological stamina enables him to persist through challenges that would discourage leaders with shorter-term orientations, maintaining effort and investment in long-term objectives even when short-term conditions suggest alternative approaches. For entrepreneurs seeking to develop similar long-term planning capabilities, the process begins with identifying missions and objectives that are personally meaningful enough to justify sustained effort over extended periods. Long-term planning requires genuine commitment to outcomes that may not be achieved for many years, making personal connection to the mission essential for maintaining motivation. The mission identification should balance personal passion with objective importance, ensuring that long-term efforts contribute to outcomes that matter beyond personal achievement, while providing sufficient personal meaning to sustain motivation through inevitable difficulties. Long-term planning also requires developing comfort with uncertainty and delayed gratification. Unlike short-term planning where outcomes are relatively predictable, long-term planning operates in environments where conditions will change in unpredictable ways, requiring adaptive strategies rather than fixed plans. This uncertainty requires maintaining strategic flexibility while pursuing consistent objectives, adapting tactics and timelines while maintaining mission focus, and accepting that long-term success often requires accepting short-term inconvenience or disappointment. The implementation of long-term planning requires building organizational capabilities, financial resources, and personal skills that support extended development cycles rather than just immediate execution capabilities. Musk's example demonstrates that long-term planning isn't just about having ambitious visions. It's about building the systematic capabilities necessary to achieve those visions through sustained effort over extended periods. The entrepreneurs who master long-term planning create competitive advantages and achieve impacts that shorter-term approaches cannot match. Chapter 7: Speed and Agility. While Elon Musk is renowned for his long-term vision and patient pursuit of ambitious missions, he combines this strategic patience with extraordinary operational speed and organizational agility. This combination of long-term thinking with rapid execution enables his companies to maintain strategic focus while adapting quickly to changing conditions, technological breakthroughs, and emerging opportunities. Speed and agility in Musk's context don't mean rushing or making reckless decisions. Instead, they represent systematic approaches to minimizing the time between identifying opportunities and capitalizing on them, reducing the delay between recognizing problems and solving them, and accelerating the pace of learning and improvement across all organizational activities. This operational speed provides crucial competitive advantages in rapidly evolving industries where technological capabilities, market conditions, and competitive landscapes change frequently. Companies that can adapt quickly to new information and execute rapidly on emerging opportunities maintain advantages over slower-moving competitors regardless of their size or resource advantages. Tesla's approach to software development and vehicle updates exemplifies this speed advantage. While traditional automakers require years to develop and implement new features, Tesla can deploy software updates that enhance vehicle performance, add new capabilities, and fix problems within weeks or months of identifying opportunities for improvement. This rapid update capability transforms vehicles from static products into continuously improving platforms, creating ongoing value for customers while enabling Tesla to respond quickly to competitive threats and market opportunities. SpaceX's rapid launch cadence and iterative rocket development demonstrate speed and agility applied to aerospace engineering. While traditional aerospace companies plan launches years in advance and spend decades developing new technologies, SpaceX launches frequently and incorporates lessons learned from each flight into subsequent development cycles. This operational tempo enables faster technology development, more efficient resource utilization, and quicker responses to customer needs or technical challenges. The cultural foundation of speed and agility requires creating organizational environments that support rapid decision-making rather than bureaucratic deliberation. This means establishing clear decision-making authorities, eliminating unnecessary approval layers, and empowering employees to act on opportunities without extensive consultation or permission seeking. Musk's companies are structured as flat organizations where decisions can be made quickly by people closest to relevant information, rather than being escalated through multiple management layers that slow response times without adding substantial value. This organizational structure enables rapid response to emerging opportunities while maintaining coordination around strategic objectives and quality standards. The technological infrastructure supporting speed and agility includes systems and processes designed for rapid iteration rather than stability and consistency. This might involve development tools that enable quick prototyping, testing systems that provide rapid feedback, and communication platforms that facilitate real-time collaboration across distributed teams. These technological capabilities enable faster cycles of development, testing, and refinement while maintaining quality standards and coordination across complex projects involving multiple teams and technical disciplines. The operational dimension of speed and agility requires developing supply chains, manufacturing processes, and business systems that can adapt quickly to changing requirements rather than being optimized only for steady-state efficiency. Tesla's manufacturing approach emphasizes flexibility and rapid reconfiguration over traditional automotive assembly line optimization, enabling quick adjustments to production volumes, product specifications, and quality requirements based on market feedback and technical improvements. SpaceX's vertical integration and in-house manufacturing capabilities enable rapid prototyping and testing of new technologies without being constrained by external suppliers' development timelines or capacity limitations. This operational flexibility enables both companies to maintain rapid development pace while scaling production and improving quality simultaneously. The strategic application of speed and agility involves identifying areas where rapid action creates disproportionate advantages while maintaining strategic patience in areas where hurried action would be counterproductive. Not all activities benefit from acceleration. Some require careful deliberation, extensive testing, or gradual development. The key is distinguishing between opportunities where speed creates advantages and situations where patience produces better outcomes. Musk's companies excel at making these distinctions, moving rapidly on software development and operational improvements while maintaining careful, systematic approaches to safety-critical systems and long-term strategic planning. The risk management dimension of speed and agility requires developing systems that enable rapid action without creating unacceptable safety risks or quality compromises. Speed without adequate safeguards can lead to catastrophic failures that eliminate any advantages gained from rapid execution. Both Tesla and SpaceX have developed sophisticated testing and validation systems that enable rapid iteration while maintaining high safety and quality standards. These systems enable fast learning and adaptation without compromising the reliability and safety that are essential for customer confidence and regulatory compliance. The human resource dimension of speed and agility requires hiring and developing employees who thrive in fast-paced environments while maintaining high-performance standards. This means finding people who are comfortable with uncertainty, capable of making good decisions quickly, and resilient enough to handle the stress that comes with rapid operational tempo. It also means creating compensation and career development systems that reward speed and adaptability rather than just consistency and process compliance. The communication requirements for maintaining speed and agility include systems for sharing information quickly across organizations while avoiding information overload that can slow decision-making. This requires careful balance between transparency and focus, ensuring that relevant information reaches decision-makers quickly without creating noise that interferes with effective action. Musk's personal communication style models this balance, providing clear direction and strategic context while empowering teams to make operational decisions autonomously within established frameworks. For entrepreneurs seeking to develop similar speed and agility capabilities, the process begins with identifying bottlenecks and delays in current operations that prevent rapid response to opportunities or problems. This analysis should focus on decision-making processes, information flow, resource allocation systems, and organizational structures that create unnecessary delays without corresponding benefits. The implementation of speed and agility improvements requires systematic attention to cultural, technological, and operational factors that enable or constrain rapid action. Cultural changes might involve shifting from risk avoidance to intelligent risk-taking, from perfect planning to rapid experimentation, and from hierarchical decision-making to distributed authority. Technological improvements might involve better communication systems, faster development tools, and more flexible operational infrastructure. Operational changes might involve streamlined processes, reduced approval requirements, and more agile resource allocation systems. Musk's example demonstrates that speed and agility aren't just about working faster. They're about creating systematic advantages through superior responsiveness to opportunities and challenges. Companies that master speed and agility can maintain competitive advantages even when facing larger, better resource competitors who are constrained by slower decision-making and execution capabilities. Chapter 8. Building Future Industries. Perhaps the most extraordinary aspect of Elon Musk's innovation mindset is his ability to identify and create entire industries rather than just competing within existing markets. While most entrepreneurs focus on improving existing products or services, Musk systematically identifies fundamental human needs that aren't being adequately addressed and builds entirely new industries to serve those needs. This industry creation capability begins with systems level thinking about humanity's long term challenges and opportunities. Instead of asking, how can I build a better product? Musk asks, what industries need to exist for humanity to thrive? This perspective enables him to identify opportunities that others miss because they're thinking too narrowly about current market conditions rather than future civilizational needs. The creation of new industries requires extraordinary vision, patience, and resource commitment because you're not just building products. You're building entire ecosystems, including suppliers, customers, regulations, infrastructure, and cultural acceptance. Tesla didn't just create electric vehicles. It created the electric vehicle industry, including charging infrastructure, battery supply chains, and consumer acceptance of electric transportation. SpaceX didn't just create rockets. It created the commercial space industry, including launch services, satellite constellations, and space transportation systems. Neuralink isn't just developing brain-computer interfaces. It's creating the neural technology industry that could transform how humans interact with information and artificial intelligence. This ecosystem approach to industry creation enables Musk's companies to capture more value and accelerate industry development more effectively than companies that focus on single products or services. By controlling key components of entire value chains, his companies can optimize system performance rather than just component performance. The regulatory dimension of industry creation requires proactive engagement with policymakers and regulatory agencies to establish frameworks that enable innovation rather than constraining it. When you're creating new industries, existing regulations often don't accommodate new technologies or business models, requiring collaborative development of new regulatory approaches. Musk has consistently invested in regulatory relationships and policy development, understanding that new industries require supportive legal and regulatory environments to reach their full potential. This proactive approach prevents regulatory constraints from limiting industry growth and ensures that policy development keeps pace with technological advancement. The talent dimension of industry creation requires attracting and developing people who can work effectively in uncertain environments where standard practices and established expertise may not exist. Creating new industries requires entrepreneurial employees who can solve problems without precedent and build systems without blueprints. Musk's companies have developed distinctive cultures that attract people motivated by mission achievement rather than just career advancement, enabling them to recruit talent capable of building industries rather than just optimizing existing operations. Conclusion: thinking like an innovation revolutionary. As we conclude this exploration into Elon Musk's mind, it's important to recognize that what we've discovered represents more than just business strategies or management techniques. We've uncovered a comprehensive system of thinking that enables extraordinary innovation and transformational impact across any field or industry. The 8 frameworks we've explored: first principles thinking, mission-driven vision, iterative innovation, risk and failure embrace, physics-based problem solving, long-term planning, speed and agility, and building future industries, work together to create a holistic approach to problem solving and opportunity creation that can be applied to any challenge requiring breakthrough thinking. Musk's success isn't the result of supernatural intelligence or unlimited resources. It's the direct result of systematic thinking processes that enable him to see opportunities others miss, solve problems others consider impossible, and persist through challenges others would find discouraging. These thinking processes are learnable skills that anyone can develop with practice and commitment. The same mental frameworks that have enabled Musk to revolutionize multiple industries can enable you to achieve breakthrough results in whatever areas you choose to apply them. The innovation mindset is ultimately about developing the courage to question assumptions that others accept as unchangeable, the patience to work toward goals that may take years or decades to achieve, and the resilience to learn from failures while maintaining focus on ultimate objectives. It's about understanding that the greatest opportunities often lie in areas where conventional wisdom says success is impossible, where established players have given up, and where the challenges seem too complex for simple solutions. The practical application of Musk's innovation mindset begins with small changes in how you approach daily problems and decisions. Start questioning assumptions you've never questioned. Look for opportunities to apply first principles thinking to challenges you're facing. Consider how your work could serve larger missions that extend beyond immediate personal benefit. Begin experimenting with rapid iteration approaches that emphasize learning over perfection. Develop comfort with intelligent risk taking that prioritizes education over certainty. Apply systematic analysis to problems rather than relying on intuition or conventional approaches. Most importantly, develop the patience for long-term thinking combined with urgency for short-term execution. The combination of strategic patience with operational speed enables pursuit of ambitious goals while maintaining progress through practical actions. The innovation mindset doesn't guarantee immediate success or eliminate the possibility of failure. What it does provide is a systematic approach to creating breakthrough results that compounds over time as your capabilities and understanding improve. The men and women who will shape the future are those who can think beyond current limitations while taking practical steps toward better possibilities. They understand that extraordinary results require extraordinary thinking, and they're willing to develop the mental frameworks necessary for achieving those results. Elon Musk's example demonstrates that innovation isn't a mysterious talent reserved for a gifted few. It's a systematic capability that can be developed by anyone willing to think differently and act consistently over time. The frameworks that have enabled Musk to build revolutionary companies and transform entire industries are now available to you. The only questions are whether you'll have the courage to apply them and the persistence to continue applying them when results aren't immediate. Your transformation into an innovation thinker begins with your next decision. Will you accept conventional limitations, or will you question them? Will you focus on immediate obstacles, or will you envision long-term possibilities? Will you avoid risks, or will you embrace intelligent risk-taking as essential for breakthrough achievement? The choice is yours, and the frameworks are in your hands. Elon Musk's mind has been open to you. Now it's time to develop your own innovation mindset and create the breakthrough results you're capable of achieving. The future belongs to those who can think like revolutionaries while acting like practitioners. It belongs to those who combine visionary thinking with systematic execution. It belongs to those who refuse to accept that things must remain as they are and commit to creating things as they should be. Welcome to your innovation mindset. Welcome to thinking like someone who shapes the future rather than just responding to it. Welcome to the mental frameworks that enable extraordinary achievement in an extraordinary time. The revolution in your thinking starts now. The transformation in your results begins with your first application of these frameworks. The future you create depends on the innovation mindset you develop starting today.